Hi, Assalamualaikum warahmatullahi wabarakatuh. So today we would like to present our GSS 613 project, which is location analysis for mall. Before begin our presentation, allow me to introduce the member of our group. I am Azwa Binti Ahmad Razali, and we have Irdina Syasya, Noor Aqilah, Nurfairuz Syazlin, and Noor Camelia Hany. Together we have a collaborate on a project, location analysis for mall. For today's discussion, we would like to start with our introduction and then we go to the methodology, result, and the last one is conclusion for location analysis for mall.
This project focused on solving spatial problems using GIS technology to analyze the location suitability of Lotus and Giant malls in Selangor, Malaysia. With growing demand for retail development, the aim is to support better decision making for mall locations that are strategic, accessible, and meet population needs. We started by collecting spatial data from trusted sources. Administrative boundaries were extracted using Diva.js, road network data was sourced from OpenStreetMap via GeoFabric, and residential zone data was obtained from the Department of Statistics Malaysia to understand population distribution. More location data for Lotus and Giant was gathered from their official websites and mapped in ArcGIS Pro. In ArcGIS Pro, we use tools like catchment area analysis and location allocation to evaluate existing mall service areas and suggest better location if needed. A literature review of similar GIS-based studies helped refine our methods and guided data interpretation, ensuring the analysis was supported by proven approach in retail location planning.
So next, we will move on to the next topic, which is methodology. For the methodology, we have three elements, which is data collection, catchment area, and location allocation. So first thing first is about data collection. For the location analysis of shopping mall in Selangor, Malaysia, we collect both spatial and non-spatial data from a variety of open source platform as well as from the official website. Once the data were collected, it was prepared for the spatial analysis using ArcGIS Pro. So as stated in this table, it shows the data type, source, and the purpose. The data type that we collect is about a road network, administrative area, residential zone, Lotus store location, and Giant store location. We use the GeoFabric website to obtain the road network data for the whole Malaysia. Then we overlay it with the administrative boundary data to clip the road within Selangor only. While the population zone data by district from the DOSM website was used to identify the high demand areas for the location analysis of Lotus and Giant Mall. A total of 18 location for Lotus and 13 more location for Giant was successfully collected from their official website.
Okay, now I will be explaining the catchment area method used in our GIS-based study on the location suitability of Lotus and Giant malls in Selangor. We applied the catchment area method to understand how far people are willing to travel to reach these malls. It helps us see the actual service coverage of each retail facility and plays a key role in solving spatial problems related to accessibility and planning. As shown in the map, the green shaded areas represent zones within a 15-kilometer driving distance from each mall. This was done using ArcGIS Pro, specifically the network analysis tool, which gives a more realistic view of travel distances compared to straight line measurements. To do this analysis, we combine different datasets such as the Selangor boundary from Diva.js, road networks from GeoFabric, and residential data from DOSM. We also plotted the actual locations of the malls using coordinates from their official websites. The results show that central and southern Selangor are well served, but eastern and rural areas have limited or no access. By overlaying the catchment areas with population data, we could clearly see which communities are underserved. This insight is important because it helps decision makers identify gaps and plan where new retail facilities should be built. Overall, the catchment area method gave us a strong foundation for the next step, which is conducting a location allocation analysis to suggest better mall placement in the future.
Location allocation. What is actually location allocation means? It's a mean of match demand and supply location based on accessibilities using GIS. So, in simple terms, it's a process of GIS that help us answer two key questions, which is number one, where should shopping mall be located? And number two, who should they serve? So it does this by combining demand data, which is like where people live, and also the supply data, where mall currently exists. And accessibilities is actually how easy it is to get there via routes. So step one, determine demand. We use the residential zone data from the Department Statistic Malaysia to identify area with high population density. So these zones are our demand point, and other words, area that really need shopping access. So the more people live in area, the higher demand we want. So the step two is identify supply, which is we gather the actual location of shopping mall from official center or official websites, and then we got 18 Lotus store and 13 global store across Selangor. And step three, which is analyze accessibilities. This actually help us analyze how well each residential area is connected to nearby mall. Because, all right, let's be real. A mall that looks close on the map but takes 30 minutes to reach by car is not very convenient, right? So, it's the location allocation process itself that we would like to present, which is using Achis Pro. We match the demand zone to supply location, then us. Are any areas being left out? Can we do better? Or should we put new mall to serve more people effectively? So we test different objectives like minimizing travel distance, maximizing population coverage, and ensuring everyone gets fair access and not just urban center. So that's allocation.
Catchment area analysis is a tool we use to understand how far people in different residential areas need to drive to reach the nearest Lotus or Giant Mall. In this study, we focus on actual driving distance rather than time by using 5 km, 10 km, and 15 km range as a parameter to reflect real-world travel along road networks. We have differentiated this distance by using three different colors, which is green for 5 km, pink for 10 km, and blue for 15 km. The results show that central neighborhoods like Puchong typically have a mall located within just 5 km, making it easy for residents to access shopping with a short drive thanks to their area's close proximity and well-connected roads. On the other hand, suburban or outer areas such as Banting fall outside the 5 km range of any Lotus or Giant Mall. So, the nearest mall for Banting is 10 km within 10 km. This means that residents in these areas often have to travel longer distance just to reach essential retail service. The analysis highlight a clear gap between central and outlying communities in terms of accessibility. By identifying these underserved areas, we can suggest adding more Lotus or Giant malls to locations that currently lack nearby access, helping to create a more balanced and inclusive community for everyone.
For the next result, we focus on the location allocation by using a 15 kilometers driving radius from the residential areas. This means we use the actual road networks but not the straight line distance. It is one to get a more realistic view of the travel time. We identify the nearest mall, mainly Lotus and Giant. It is to see how accessible they are to the community area. From the map, we can see that high density areas have a good coverage with multiple access points, but there are some areas are still underserved. This analysis will help us on the future plan for outlet locations or improve the service coverage. We can also use this data to avoid placing outlets too close to each other, and in the future it may consider the traffic conditions that may affect the driving time. Next, I will pass to the conclusion.
Lastly is about the conclusion. All 31 malls were successfully being geocoded using catchment area and location allocation methods. Catchment area analysis provide a more accurate assessment of the actual service zone of each mall based on travel accessibility. Meanwhile, the location allocation model demonstrated how well mall placement was correlated to the surrounding high-demand residential zone. GIS will be good analysis are the quality of current mall, distribution and future retail mall in Selangor. Finally, this study successfully done with application of GIS to analyze the location, distribution and accessibility of the mall using spatial dataset from GeoFabric, Diva GIS and the Department of Statistics Malaysia (DOSM). So that's all from us. Thank you.